All right, so recording has begun. Um, Thanks for the confirmation. You all have activated credits. So, like I said before, we are going to build and deploy a dynamic hybrid retail search with AlloyDB, Gemini, and Cloud Run. So the first introduction page explains the need for a hybrid search approach in this day and age, because with all these advancements in AI and generative AI and agentic AI, search is getting more and more sophisticated, which means you're not just typing, you're not just choosing from menu items, you're not just using faceted filters. You want a combination of both. And in addition to that, you want to type or just speak what you want to search for. You want the system to automatically dissect that into multiple menu items or filters and understand the context you're looking for, and behind the scenes perform a high performance search comparison for you and deliver the results. So that is exactly why we need a sophisticated search based e-commerce solution now, or rather sophisticated search hybrid search solution in this AI advanced state of times. All right. So we are going to build this application. I have already told you that it's going to be data driven. So we are going to use AlloyDB and its advanced AI capabilities. So right when I said search, you would have guessed we are going to use a RAG-based application. But this is not just a simple RAG that we did last year or earlier seasons of Code Vipassana. This RAG is going to be one, advanced in terms of how recent the embedding algorithm is and how multimodal the embedding algorithm is. You all know that text embedding, image embedding, that is multimodal embedding, is also supported with Vertex AI, which is what AlloyDB is also able to inherit. Right? And we also know that since AlloyDB supports scan index, which is scaled approximate nearest neighbor index, it means your performance of indexing based search results, it's also really fast because it is focusing on the approximation of the nearest matches for your search, which means your search is going to be fast. And in order to ensure that your search results are of high quality, you also are provided with a re-ranking capability in AlloyDB AI when you're using scan index, which means, or when you're using this kind of indexing algorithms, which means once the search, there is embedding based search results are retrieved, you're able to kick off a re-ranking on the resulting rows, because you want to again ask the algorithm to reconsider and re-rank the matches to make sure that are relevant to what the user is looking for. All right. So that's why re-ranking is there. And on top of that, we have a way to calculate the recall percentage of the matches. So recall means how many true positives has the search returned. So if I'm searching for white polo t-shirt, and if the search results have retrieved 10 results, and out of which 9 are accurate, my recall is 9 divided by 10 into 100, right? So based on the recall performance, you're able to change the algorithm's parameters, or the scan indexes, or any index for that matter, indexing algorithm that you're using, the parameters of your search itself, and then rerun to reevaluate the recall and improve your performance. So why is this important? You will not be thinking about this if you're just building a hello world application or something that's on the surface. You will really think about this when you're solving a real business problem, when your customer is demanding you to reduce the search time from 10 milliseconds to 5 milliseconds. That's when you'll realize the need and importance for all of these things. However, we are, without diving too much into the depths of how to do it step by step, although all of those things are made available for you in this code lab, we'll deploy this application and then we'll walk through the different aspects of the query itself. All right. So that's what is detailed here in the overview, challenge, and objective. So like I said, what are you going to build? In this code lab, you're building an AlloyDB instance and table, and then creating embeddings and performing vector search to do the comparison. And then you're creating metadata index. What is metadata index? So an e-commerce data set will consist of, say, all the parameters of your retail data set itself, like category, gender, color, material, type, so on and so forth. So each column itself will have so many thousands of unique parameters if it is there, right? And if you are in a scenario where you have to index each of these columns, and if that works and if that is applicable and really needed, and this is more often than not needed, because that's how e-commerce applications work. You'll need to index them because the users will search on any or filter by any of these columns, right? So you will create indexes on each of these columns. What is an index? An index is a bookmark to execute the search much faster. And what is an embedding? An embedding is a numerical representation of your data itself. So when you're indexing and when you're indexing the embeddings of data, it means the search is going to be super fast because you're indexing the numerical representation of the data. So it's much faster. That's why we are saying it's advanced in performance and quality. Now, metadata index is just a plain old column field-based index, which is something that you would have traditionally done if you are a database developer. You would, or an application developer or a software engineer who's used databases in the past, you would already know a simple metadata index is a column index. And the scan index is depending on the advanced algorithms that we use. Now, lucky enough for us, AlloyDB supports all of these things. Scan index and other algorithms that you want to use, KNN, and then metadata index and all that. It also supports all AI, Gen AI, and agentic AI capabilities by integrating directly with Vertex AI. All right. Then what we're going to do, we are going to allow inline filtering method for the scan index, and then set up facet filters and hybrid search all in a single SQL query. And then we will use re-ranking and recall options to refine the query's relevance. And we'll evaluate the query's response with Gemini. And then we'll see how so much of database operations, so many database operations are simplified with a simple interfacing layer called MCP Toolbox for databases. It is a simple MCP Toolbox server that separates your agentic or Gen AI application or your data-driven application from your database layer or your query layer. So that is the interface, the control plane layer, which is called MCP Toolbox. And finally, the application development itself in Java, which includes all of these things just by interacting directly with the MCP Toolbox. That's it. This is what we're going to build. It seems like a lot, but don't worry, I'm not going to start from the scratch and do all these 8 steps to get to the 9th step. We'll start directly the 9th step. We'll first build the application. I'll then deploy this along with you all, and then I'll show you where MCP comes into picture and what are the queries you're using, all with the GitHub repository we'll go through. All right, ready? Show of thumbs or raise your hand to confirm that you got to this point, understood everything. Yeah. Okay. Thank you. Thanks. So we've got about 25 hands up. I'm hoping that's a good sign. All right. So now before you begin step is still mandatory because you're going to create a project. So we've already created a project. We've already enabled billing account. We've already linked those two. Great. Now go back to the console where you have that open. Now you have your project picker showing your active project. You have the search bar. You have Gemini button right next to it. And right next to it, you see an activate Cloud Shell button. Go ahead and click that. It should open Cloud Shell terminal. So Cloud Shell Cloud Shell, when you activate, comes with 2 things. One is Cloud Shell machine and another is Cloud Shell terminal. It'll ask you to authorize. Go ahead and click authorize. Cloud Shell terminal will allow you to enter CLI commands that allow you to interact with all of Google Cloud services and anything that you want to do from command line. Cloud Shell editor is where you write code or maintain MD files or text files or whatever you want. It's just an editor where you can do stuff, maintain your projects. All right. So by combining the power of editor and terminal, you can bring your whole development experience here. Okay, so we've done that step. Point number 4, we'll skip that for now. We are going to wait until the terminal loads. So let's give it a couple of minutes here. All right, so there we go. My tab is loaded. The terminal window is loaded. And I see my active project, CVS11-Abi, showing up there. I hope this is the case for you as well. If you don't see your active project right here, right next to your username, that's a problem. I mean, it's easy to solve. If you go back to the code lab, in point 6 of step 2, there is a command that says gcloud config set project, and within parentheses, angle brackets, it says your project ID. So I would copy from gcloud to project and then replace the last part with your actual project ID. So how do you get your project ID? Remember the project picker, which shows your active project? Go ahead and click that without fear. It won't reset anything. Now you have name and ID. You don't want the name, you want the actual ID. So I'm going to copy that. Copy the ID and keep it somewhere handy. You will use it in multiple places today. So save it somewhere handy. Okay, I'm going to just keep it in my text pad. All right, now I'm going to, if you don't see the gcloud, your project name showing in the terminal prompt, then type the command or copy the command from the code lab, gcloud config set project and the project ID that I've just copied, and hit enter. It's already showing that, so I didn't have to do it, but anyway, it updated in my case. All right, perfect. So now that is done. The next thing is to enable the required APIs. So how do we enable the required APIs? There are multiple ways to do it. You can write gcloud commands, or you can go to the service one by one and enable it at the time of usage. But for convenience, I have consolidated most of the services that I may have missed a few, but then let's see. Right click on the link and copy link address. You see that the 0.7 in step 2 before you begin step is scroll down to the last to 0.7. You will see that the word link is hyperlinked. So right click on the word link, copy link address, and just make sure, paste it in the text pad and make sure make sure what you're seeing. You're seeing AlloyDB. So we are enabling AlloyDB because, like I said, in a typical environment, if you're starting from scratch, you will set up the AlloyDB instance and everything. So we need that. We need compute, we need cloud resource manager, we need service networking, we need run, we need cloud build, we need cloud functions. All of these things, apart from AlloyDB, are because we are going to deploy this in Cloud Run. So those services need to be enabled. Now, cloud functions is optional, but we have used cloud functions as well. So enable that as well. Next, AI platform, which is Vertex AI. It shows some UTM campaign and all. Thankfully, I noticed that. Please forget about that and just copy the first part. Copy from console.cloud.google.com till AI platform.googleapis.com. Copy that and open a new tab, or rather go back to your Cloud Console, right click on your Google Cloud logo, open link in new tab, and oh, you didn't have to. You just have to open a new tab and paste this URL in the URL placeholder, and then you will see that the API enablement screen will show up. There we go. Enable access to APIs. First, it's asking me to confirm project, and the project it is showing is wrong because it is automatically logged into another ID. So I'm going to close that. Don't worry, this won't happen for you. This is for security reasons. It always logs into my work account. Okay, now it is showing my active project. So confirm your project first. Make sure if it is different for you, go back to the project that you're working on, because if you are working in project A and you're enabling APIs in project B, then it won't relate. It is not relevant to each other. So now I've confirmed that CVS11-AB is my project. So I'm going to click next. It says I'm about to enable all of these services. I'm okay with that. I'm going to click enable. Now this will take a few seconds. I'm going to let it go through the enablement step, and then all APIs access are enabled in a few seconds. While that happens, let me power my laptop. Okay, it's still enabling for me. Show of thumbs, how many of you got through the step? Show of hands. Okay, a lot of you have got the step done. Good to know. Mine is still enabling. Okay, I see 2 tick marks, and it says you have successfully enabled all of these bunch of APIs that the whole bunch of APIs that I just enabled. Cool. You can just close the new tab or whatever it is that you're doing. You can just come out of that and go to your main console where your terminal is open. All right. Now go back to your code lab. We're done with step 2. Now, step 3, step 4, step 5, step 6, and 7, we'll come back to those later. This is where I said we are going to set up database, create embeddings, perform vector search, understand the RAG, understand all the performance and quality related aspects of it, and how we are accomplishing this in the project. And then MCP toolbox. All of that is already taken care of for you. So we're going to skip past all those steps and go to step 8 directly. Not that I'll not cover those. We will go back and review how it is implemented, but let's first get the application developed and then we'll backtrack it. I figured I originally didn't plan to go this route, but then I thought, how many times have you all created AlloyDB with me in a similar session? So I thought, okay, for a change, let's just go the other way around. We'll do the application first and then we'll address the different elements. I'm sure you all know how to already install and set up AlloyDB and ingest data and all that. We have done that several times in past. If you don't know, we will go through that anyway. All right. So now jump to step 8, which says application development, Java with faceted search. Now, if you're not a Java developer, if you are from a JavaScript background or a Ruby or a Python or a different programming language for that matter, don't worry about it. I'm not going to ask you to learn this programming language to complete this. We will look at the design aspects of it. Programming language can be of your choice when you're actually implementing it on your own. For this lab, however, stick with me and just proceed. We are just going to do a Git clone. I'm going to explain what is happening. You can relate to it in your own programming language or tech stack or framework style. Okay, but still go ahead and do the steps with me because it's not very complicated. We are going to clone the repo. It's pretty straightforward, you'll see, because we have compartmentalized the whole implementation in that way, as I explained to you in the beginning in the design process. All right, so now we already have this open, the terminal. So I'm going to copy the git clone command from here. Yeah, just copy that in step 8. Come back to your terminal, paste that and hit enter. Oh, no space left on device. Oof. Okay, so let me do one thing. I'll just quickly jump to another project. Meanwhile, you go ahead and clone it. Since I have multiple projects and several projects within the Cloud Shell machine, that's why this is happening for me. So I'll clone it in a different project. Please ask your questions in chat if you don't mind. We are not going to allow you to speak or ask questions. So don't put your hand up unless we ask for it. Use the chat to ask your questions. Please use chat to ask questions or say anything that you want to, even if it's not a question. We are very vigilant in the chat. I'm just waiting for my Cloud Shell terminal to load. So if yours is loaded, just go ahead and I see Sai Sarika's hand is up, Akash's hand is up. Please go to the chat and type your message there, if that's okay. All right, so I'm going to do a git clone in my Cloud Shell machine. So it's loaded. Yes, Sai, go ahead and type in the chat, please. Whatever you want to ask, please ask in the chat. Folks, leads, can you please check if folks are not able to send your chat message, send a chat message or something, because after Leon's, I've not seen any other message. Yeah, Sai and Sonu, Akash, please go ahead and send messages in the chat if you have questions or messages. Yeah, API enablement step we have crossed already in detail. All right, Sai Sarika, you had a question. Go ahead and type there, please. I apologize for not realizing that the message was off, or I don't know if it was off, but others are able to message. So if you're not able to, kindly refresh and come back. Yeah, so we are going to Code Lab. I'm just quickly going to show how to enable APIs. It is there in step 2 before you begin step. Scroll down the page, point number 7, enable the required APIs, follow the link and enable the APIs. You should see the line. And in that line, you see the word link is hyperlinked, which is blue in color. Right click and copy the link address. If you copy the link address, you will be able to open that in the same login session as your Google Cloud Projects login, user login. Open that in that window or in a tab within that window. You should be able to activate or enable the APIs just by clicking next. That's it. And then enable. That's all. Once that is done, all you have to do is jump to step 8 and copy the git clone command. Come back here in your Cloud Shell terminal and hit enter. That's it. It's done. The cloning is done. So now what we have to do is click open editor in your Cloud Shell terminal, just like you can see in my system. In my Cloud Shell terminal, there is an open editor button on the top of my terminal. Click that open editor button. It will take a few seconds for the editor to load. The reason I'm opening this is I want to show you the folder that has just been created with the source code that we have just cloned from the repo. So I'm going to go to meeting. I'm going to ask you, please show of hands, how many of you were able to complete git clone? Awesome. Cool. Thank you for sharing the activation enabling link, Mohan, but it's not necessary. It's there in the code lab. Folks, please listen to the steps carefully, because if we miss one, we're going very slow today. So don't miss a step. Huh? I'm giving enough time because I know that some of these things will take a little bit of time with the activation of Cloud Shell Terminal and other things. Okay, so you should be able to open your Cloud Shell Terminal like this. You probably will not have so many projects. Whichever one you just cloned, that will be showing up. Go ahead and expand that project. So in my case, I'm going to expand the faceted searching retail project, which I just copied. If you notice, there is a folder called Cloud Run function. So I would request you to delete that folder for now. All right. I'll explain what that folder contains, but that's not needed because you're not going to create the Cloud Run function. I've already deployed. I'm going to give you the link to it, the endpoint to it. So you won't have to deploy a Cloud Run function. The reason I'm doing that is to save your resources, but at the same time to get through the entire session and walk through what we have done. So you can do it at your own time whenever you need to do for your application. Yeah. So delete only that Cloud Run function folder with all its contents. Oops, I clicked download instead of delete. Okay, delete permanently, delete. Okay, I've deleted that folder after I cloned it. Okay, so now you see retail faceted search inside the faceted searching retail folder. Now delete the folder. So you also need to delete the dbscript.sql. Delete that also. Don't worry, I have the GitHub link for that. You will be able to view all of this. Go ahead and right click dbscript.sql and delete permanently that as well. Next, delete the file tools.yaml. Delete that as well. You don't need it to need that to be deployed as one of the files because all of that is already done. I'll explain to you what we have done, but for now, delete it. So we have deleted 3 things. One is the entire folder called Cloud Run function within the faceted researching retail. There is a main project folder. And we have also deleted dbscript.sql file. We have also deleted tools.yaml. So why we deleted these 3? Because these 3 are given for your reference. These 3 should be deployed elsewhere. But I just put it in the same folder for reference purposes. And since we cloned the entire repo, these also got copied over. So I asked you to delete. But when we are going through the explanation for what this is doing, we'll go to the GitHub repo and review these files again. So don't worry, just delete these 3 things. And now navigate into the retail faceted search folder, which is the actual project contents with source files. So expand src, expand main, expand java, expand web. You'll be seeing 3 files inside web, which is product.java, product repository.java, retail controller.java, and retail application.java, which is one level outside the web folder. All right. Now, in the product repository.java, go to product repository.java. You have to modify toolbox endpoint with the endpoint that I'm going to share with you. All right. Search for. So you can take the variable name from the code lab itself. If you're in step 8 of the code lab, point number 5, where it says in the file product repository.java, you have to modify the toolbox underscore endpoint variable. So copy the toolbox underscore endpoint variable endpoint text and search in product repository.java. It will bring you to the hard coded value. Typically, you will have to use environment variables, but just for sample, I have given it as a hard coded value here. It's very simple to store it in an environment variable at the time of deployment. I'll show you how. But right now, I'm just going to hard code it here. Yeah. So just remove the part where it says your project number. I'll give you the actual endpoint link. Just a second. Okay. Meanwhile, complete the other steps we've discussed so far. Let me give you the endpoint quickly. Okay. So I'm sharing the endpoint to you in this meeting call, meeting chat. I'm going to pin this. Copy this endpoint or just copy those numbers in that endpoint. Come back to your application where it says toolbox underscore endpoint. Replace that with this particular link that I just shared, endpoint that I just shared. The last slash is not needed. Remove that. Remove the last slash, please. Yeah. Cool. Save that. So show of hands, how many of you got to this point and replaced toolbox endpoint? So the toolbox endpoint will only be shared now. I'm gonna, we'll have to stop sharing that because I'm gonna start sharing my screen again. Okay, show of hands. Okay, I see a few hands. I'm hopeful that these hands are confirming me that you're able to make these changes that we discussed so far. So basically what we've done so far is we've gone to step 8, copied step 8 of the code lab, copied the command that says git clone, ran it in your Cloud Shell terminal, and then we removed the folder name Cloud Run function. We've removed the file name db underscore script.sql. We've removed the file name tools.yaml. And then after deleting these 3 things, we went to product repository.java file and we modified the toolbox endpoint with the value that I shared. Now we are going to go to step 6. Same step, point 6. And we want to make sure the Docker file and pom.xml are intact. It's always, since we have cloned it, it should be intact. Let's just still make that check. All right. I'm going to share my screen now again. So we are here. And okay, I've made the change. And now I want to go to Docker file. Just make sure what you see in the Docker file. So this Docker file is what is going to help with containerizing your entire application. That is basically package your entire application with its dependencies. It tells what version of JDK to use in this case. In your case, if you're a Python developer, this Docker file will be will be different. Of course, you'll not be using JDK, whereas you'll be using Python dependencies. Same thing with JavaScript and Node and other things. Working directory, again, you'll give a working directory here. We'll go step by step. You'll copy the pom.xml and then you'll copy the source directory's contents, and then we'll package. We are using Maven tool for packaging and building and everything. And then we are using Open JDK for base image. And then We are copying the image contents, building it, and sorry, configuring it for building. And where does it start? Where do we start the web service? Or where does it start with a build? It starts with this particular jar. Yeah, so that is exactly what we have given here. And this particular package is what we have named our packages as well. Hello world. I mean, technically it should have been something else, but I just left it with a default. So when you create an application from the scratch with Cloud Shell editor itself, it puts some placeholder package names. I just left the package name as it is without changing. It's not a good practice, but make sure your applications package and folder names are relevant. Okay, so we've seen the Docker file and what it does. And now going back, also make sure your pom.xml is intact. We are not going to change anything, but you need to see what dependencies we have. So what do we have here mainly? The main dependency, where is it? There we go. So we have Spring Cloud GCP dependencies that is needed. We have a JSON dependency for handling JSON values. And then we have Spring Framework dependency, timely dependency for front end. What else? Pretty much it. That's pretty much it. Um, I think I'm using API key instead of Vertex AI. If I'm not okay, this is not. We are handling the AI part in AlloyDB itself. So that's why you're not seeing any AI dependency here, which is pretty cool because you're handling the main part of the application, which is the AI, the data-driven part of it entirely on the database side, which is the SQL part. So that's why you're not seeing the dependencies related to data or related to AI in your application side, which is pretty cool, isn't it? That's what the entire MCP server is supposed to do. And we've accomplished that already. All right, now going back to the code lab, we have not changed anything apart from the toolbox endpoint and removal of those folders and files, folder and files. Now we are going to package, compile, and test our application locally before we deploy. Are you ready for it? Show of thumbs. Ask your questions in the chat, please. Okay, I'm hoping these hands are for completion of the step. Am I right? Someone ping in the chat to confirm, please. Say you have completed this step or something like that. Okay, perfect. Thank you. All right, now going back to the code lab. Where were we? All right, now we are going to go to terminal. We are going to package and build it. Run it locally. So navigating into the folder is really necessary, but I think we should already be in that folder. Let's see. Now you see the open terminal button on top of your Cloud Shell. Go ahead and click that. No, we are not there. We have to navigate into the directory. So how are we going to do that? Copy the CD faceted searching retail command, paste it, and hit enter. So now I'm inside that folder. One more level because we have the main project starting inside retail faceted search. So do a CD retail faceted search command as well. So now I'm inside this project folder. So we are all set. Now we're going to do MVN package. Now it's packaging it. Okay, build success. Show of hands, how many of you got your build success? Okay, once you show your hands, once you raise it, please lower it as well, because that way we want to, sorry, I'm just lost at this point, waiting to pair with you. I don't know why, what do you mean pair with you? I don't know what this request is. I'm sorry. I've never seen this request before in Gmeet. Anyway, lower your hands once you raise it so that next time I ask, I know that it's new set of folks who are confirming or new set of confirmations. Same folks. Okay. people. Thank you for that. Thank you for the confirmation. Let's move on. I'm sorry. I got a request for tile pairing. I don't think we want to do that at this point. Maybe it's accidental. Let's get started with the next step. So we want to do MVN Spring Boot run. So copy that step. Come back here to your Cloud Shell terminal and paste that command. What it does is it's just running your application locally. So make sure it gets started. The server, we are starting the we're starting the app locally. So there we go. We got a message that the container has started successfully and is listening for HTTP requests on 8080 context default. Go back to your code lab, see what it says. It is asking you to click that third icon from the Open Editor button and click on Preview on port 8080. So the third icon from there is called Web Preview. So if you hover over the third icon from the Open Editor tab, Open Editor button, you should see Web Preview button. Click that and click Preview on port 8080. There we go. Moment of truth. Please don't crash on me. Okay, worked. So basically, we are going to now dissect this application. But before that, let's first deploy this in Cloud Run, which is the most anticipated moment of the session. Why? Because that's how you know how easy it is. All that I said so far from the front end perspective, you can build with vibe coding technique. You think I'm capable of building a UI as sophisticated as this? It's not as sophisticated, but still, my taste in user interface is not amazing. I would not appreciate that myself. But I built this with vibe coding technique. I use Gemini CLI to do this. And in last session, you know how to install Gemini. You learned how to install Gemini CLI and start building the front end. But my strength is in building the application's core logic, working with the entire tech stack. I mean, before, of course, before the sophisticated user, this is not a sophisticated user interface, but there are applications which I really enjoy building now because I also started enjoying building the front end aspects of it, the user interface aspects of it, which I didn't used to in the past. And that's where Gemini CLI really helps. The advantages Gemini CLI allows you to have the convenience of your own tech stack, own programming language, own services and products, no vendor lock-in, nothing like that, right? So it's really helpful that way. But my strength comes in building the application, the core application logic, designing the whole thing, doing the backends, and making sure everything is intact end to end from a security, data, and design perspective at a point where it can scale even unexpectedly. So that is the kind of design that you need to think about when you're actually building application. And going further, this will be the reality. You will not be building user interface. I mean, I'm not saying user interfaces need not be built. Of course, you need to know the foundations and details as to what will get impacted if you add an element or remove an element or things like that. But those things have been made so easy now with tools like Gemini CLI. So if you want to incorporate a component which you've always dreamt of but don't know where to build right now, build in the past, you will be able to do all that right now. Now, let's say if I want to have tiled representation of this particular object, the shoe, the purple shoe that you're seeing here. Maybe I want to see a 360-degree view, or maybe I want to slide and have multiple images shown in the same tile. All of that is possible now. Once upon a time, I would have been like, okay, I don't even know how to get started with displaying something like some user interface like that. But now I know it's easy for me. I know my logic. I will write the math for it, but then the user interface aspects, I don't need to know all the details. That's how simple Gemini CLI has made your lives. Now, enough about Gemini CLI. Let's get to business of today, which is deploying this in Cloud Run. But before that, show of thumbs, how many of you got this to work in your local? Perfect. Thank you, folks, for confirming. Now, before getting into the details of the application itself, let's go ahead, go to the code lab. Go to the go to the next step, step number 9, deploying to Cloud Run, important step, like I've already said. All right, so now make sure that you go back to your Cloud Shell terminal, Control-C to exit from your running application, because we have seen that locally the application is working. Now we want to make sure the Cloud Run deployment is done. All right. So you see the command right here, gcloud run deploy. The app's name is retail search. That's the name you want to give to the app. You can change it to whatever you want. Hyphen source, which means the source is in the dot directory, which is in the current directory that you're in. Region, US Central 1. You can choose anything depending on the data you have. Let's just go with US Central 1 for this. Allow unauthenticated. Here I'm allowing it to be unauthenticated. But typically, you will either authenticate it with OAuth2 or whatever authentication you have for your business app. Labels. This is to relate this particular collab. Technically, you want to use this for admin and other activities, operations of your maintenance, basically of your applications collectively. So it's really helpful to identify the deployments within a specific project or within a specific label. It will help organize your cloud run deployments much efficiently. So just copy this entire command and run as such. You don't have to change anything because you've configured all the things that we need already. So paste this within the same folder, retail facility search, and hit enter. It will take a couple of minutes, and while no, it will ask you a few questions. Maybe not. We have provided all the details, so maybe it won't ask us any question. It will take a couple of minutes for this installation to complete, or sorry, deployment to complete. So meanwhile, let's go ahead and see what we have skipped so far. All right. All right. So, like I said in the design part, we have the database, which is AlloyDB, which is where our core data for the e-commerce data set lies. So let's go ahead and take a look at the data itself first. Data ingestion. If we scroll down, there is a insert GitHub repo file. So right click, open link in new tab. So if you can see right here, the insert queries link is mentioned here. I've just kept it in a separate file, so it's not crowding the GitHub repository itself. Oops. Okay, there we go. So you can just look at my screen. You don't have to click it right now and open it and go through it. You can just watch my screen because until the deployment is done, you're just going to listen to me. All right, so as you can see right here, we have the project, the product ID. We have categories, we have apparels and footwear. We have two different types of categories. We have subcategories: apparel, set, bottom wear, dress, flip-flops, innerwear, sandal, shoes, socks, top wear. So when I said metadata indexes, you would require a metadata index for fields that have more values in them, right? So let's say if subcategory is going to be one of my where clause fields, and if there are multiple records under a certain subcategory, then it's good to have your record indexed. That way, the search is pretty fast. This is a typical database setup. This is not something new. I'm not telling this anything related to generative AI or anything. This is how database typically works. The column that has when the data that pertains to a specific field has more variations or more variance, more than 100 per se is a typical standard value that we can say when an index will take an effect, right? If you have more than 100 records and you index it, the search is much faster. Why? Because for a cluster to operate, it at least needs certain number of records within a group, right? So that's when you index, you need certain number of rows. If you're building an application with 10 records, you don't need an index because your search is going to be fast anyway. You don't need to bookmark anything there. But with millions of records or hundreds of thousands of records, index is important on the fields that commonly occur in your where clause. And if you know that the where clause is going to be benefited by the field, only then you create index on the field. Sometimes people create indexes and that causes an overhead for the application itself because unknowingly they create index on a field that should not be created. That will actually impact the performance because it is not directly used in where clause. Rather, it is going to be transformed or processed in detail within the scope of that query or the application. Then applying an index on it is a waste of effort, waste of resource and everything, because it not only will it slow down your application, it will also be resource intense. So be careful when you're choosing a metadata index. These are pretty common best practices of database initial early stage like database design and stuff. But now we are talking about scaled approximate nearest neighbor algorithm and all that. But that will come into the picture of a natural language based comparison search, which is embeddings based search. So if I convert the product description that says boys kurta set, red ethnic, fab India, blah, 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 whatever description. So I have a paragraph here. So if I have to convert this into numerical format, which we have done, I'll show you that in the SQL query. And then you want to search for red kurtas for boys. So in that case, your database content is a field is also converted to embeddings and stored in the database in the table. And and in real time, whatever you're searching for in your deployed application, which we'll see right now, will also be converted in real time to embeddings. And now embeddings to embedding comparison will make it faster. So that particular embeddings field or embeddings column will have to be indexed in order to make your application perform much efficiently with high performance in, of course, quality. But when we're talking about index, we're talking about performance here, mainly performance. Yeah, so that's the main point of the indexes which we covered. Now, similarly, if you want to search by text, but you want to compare it against image embeddings, that is also possible. Let's say you don't have a field that contains description of your what do you call it, product. Rather, you have an image of your product or a video of a product. You can quickly convert it into a multimodal embedding, which is also an array of floats, which is a numerical format of your data, multimodal data, and store it in the database, which is AlloyDB itself. And now, when you're searching for yellow kurta for men or white polo t-shirts for women, then automatically it is going to convert that into text embeddings in real time, and it will compare it against the image embeddings or the multimodal embeddings that is there in the database. And irrespective of the modality of the comparison, it will be able to compare embeddings against embeddings and retrieve the closest matches for you. And given that you have enabled the scan index or other algorithms for vector search, it is going to expedite the speed of your search results as well. At the same time, we are using several other techniques for re-ranking, validation of matches, match response and other things, and recall evaluation and other factors to ensure not just the performance, but also the quality of the search results, right? So we'll see all the queries right now. But before that, let's go back to the application and see if it is being deployed. Okay, mine is deployed. Show of thumbs, how many of you got your apps deployed? Sorry, show of hands. Okay, thanks for the confirmation. Now, going to the code lab here, go to step number 5, creating embeddings. So how do we convert embeddings? So at this point, we are not going to do any hands-on. You don't have to do anything hands-on. You're going to listen, and then we'll operate on the application to see whatever we are talking about in action. All right. So embedding. So what is the query for converting text into embedding? So this is the simple method you'll call in AlloyDB. So this is a simple select SQL embedding, and the embeddings algorithm we've used is text embedding 005. There is also Gemini embedding model that is more recent. So I would encourage you to use that. Probably that was functional or something right after I published this lab first time. So I didn't go back to change it, but this is also recent. And then you can use your text to directly convert it. But if you're operating this on a database or sorry, on a table, field in a table, then you will have to use a query like this, where your embedding method will take in the algorithm name, the embeddings algorithm name, and the field name. In our case, the name of the field is PDT underscore description, which is product description. So I'll run, if I run this query, it will automatically update the embedding column in my table with the embedding value of the field product description for each row, which has product description in it, which is non-null. Yeah. So in this update query right below that, I'm calculating the image embeddings for each of the image that I've stored in cloud storage, whose GSUtil URI link is mentioned in the in one of the fields in the same table, GSUtil URI table. You don't have to like, I'm not saying you should try this out right now because you don't have the data with you. I've given you the endpoint for my data set. So you'll just be able to view that in your application. But this is for you to know how I accomplish this in the application. Moving on to sixth step, step six, perform advanced track. So now I showed you how to create embeddings, how to update the fields with embeddings values for a specific field, text field or image field. Now, why are we calling it advanced track? Let's look at that. So this double arrowed equal sign you see right here, that stands for cosine similarity. Similarly, we have other distance functions as well, which is linked probably here, or you can just search for distance functions or similarity algorithms in supported by AlloyDB. You'll get all the items there, like Euclidean distance and other distance methods. So we've used cosine similarity. This means the field embedding, which is in the database in apparels table, is checked against your real-time search text, which is if I'm searching for t-shirt with round neck, it is going to convert that into embedding and check against this embedding. Now, instead of text, if you have an image with a VSUtil, which is Google Cloud Storage URI, you can also pass that and use the multimodal embedding algorithm instead, and then run the same method. So it's so compatible now. You can just compare text against multimodal data or multimodal data against multimodal data. So many things are possible with that when it comes to a retail world. Moving on to the next one, AlloyDB takes vector search RAG to the next level. So this is where I told you about scalable nearest neighbor or scaled nearest approximate nearest neighbor algorithm. So these are the steps how you get to it. You generally create the AlloyDB scan extension if it's not already there. Basically, you're telling the system that, hey, I'm going to use scan, so please enable the extension for me. And then you're going to create the index. So I'm creating apparel index and apparel image index, both on what field? Embeddings field. One is the text embedding, another one is the image embeddings field. So I'm creating index, scan index on these fields. But mind you, I have used the same algorithm that I've used in vector search to create the index. If you use Euclidean distance in your vector search and create the index with cosine similarity distance method, then your application's performance will be impacted negatively. You have to, this should be compatible. You have to use the same algorithm for creating the index as well as applying that index using vector search. All right. And then metadata indexes, like I said before, I have used the category, subcategory, color, gender fields to create indexes on them. So I've created 4 indexes on these fields because there's a lot of data that goes into each of these categories, and these fields go into the where clause more often than not. Why are you saying more often than not? Don't you know at the time of beginning your application? That should be the question that's popping in your head right now. I'll tell you exactly why. Why is it not static anymore? It's dynamic. My application decides at runtime what goes into the where clause of my search query, depending on what the user types or searches for, or a combination of both. So that's why I call it hybrid search. Because at runtime, my application, based on the configurations I've done in AlloyDB, decides whether the filter based on your indexes, the normal metadata indexes, and your RAG indexes need to be run in tandem, which is at the same time, or one should be run before, which is like your RAG index must be run, the scan index must be run after the metadata index, or vice versa. This is something that you can let AlloyDB decide if you just turn on the inline filtering method. Okay. Now, faceted filters. You might be wondering what the hell is faceted filters? You've been saying this quite a lot in this session. So faceted filters is something that typically not just choosing a menu item and filtering by it. That's just where clause, right? Faceted filters were one stage ahead or once that came one stage after the typical good old menu based filters. So what you see in our application right now, remember how our application is deployed? Right click and open this application now. It's time for us to do that search. Open your application here. You see that the filters in the left side, these are called faceted filters, which means you're not choosing one menu item and passing it in the where clause. You're choosing multiple menu items across multiple categories, may or may not choose a bunch of these, right? Let's make some sense. footwear and not apparel. All right, and I'll say dress shoes and hit enter. Right. So this is what we call as faceted filters. This is very common in e-commerce sites. In all the e-commerce sites that you use, you would have seen it, right? It's different, of course, from the typical metadata index based normal menu based filter search because it allows you dynamic thing. But now in our case, we are doing RAG on top of all of this. Now, if I want to add another feature where I say I put an upload button here and say upload an image or take a snap of a shoe you like and search for similar shoes in our repository, you can do that as well because you have image to text or image to image embedding comparison as well. So many things are possible. Basically, long story short, read the code lab for more details if you like, or just read AlloyDB's documentation as well. Hands-on, there are so many hands-on applications that I have published in my Medium blog as well as code labs. So you'll be able to explore this in more detail if you have the time. But for now, long story short, this is what we mean by hybrid search, which is you're typing here at the, oops, I locked my system. Okay, I got carried away. Yeah, so you're just typing your requirement here, you're choosing here, and all of these things are happening in real time. It's not having static filters. It is filtering dynamically. We'll see the query now. You must be wondering, okay, show us the query. You've been talking about this so much. I'm going to show you right now. But before that, just know it's not just forming the query dynamically, which you can say this I used to do even before AI or even before AlloyDB, but not just that. Behind the scenes, the indexes are chosen at runtime because I've enabled the indexing, the parallelization feature here. All right, so now let's move on to the query part. Show hands, how many of you are bored? Okay, thank you for being honest. Okay. Thanks for being honest. I'm going to stop the theory here, but let's go to the code lab and see what is up next. Okay, so I've showed you all of these things. Okay, one more thing which I forgot to show you is the re-ranking and recall evaluation. Recall evaluation is fine as just a method. It's there in the code lab. Go to step number 6 of the code lab, advanced rank, right? So if you scroll down, there is a query that says with initial ranking. So if you see right here, the basic query which you have in the bottom, not the bottom, in the top, which does the cosine similarity algorithm, right? So that vector search, so that is the basic RAG which we have done. But on top of that, we have used a ranking method to re-rank the results that we have already got. All right. So the topmost, just watch my. Are you not able to see my screen?
You're not presenting.
Oh, thank you for that. When did I stop presenting?
I think after the theory.
Okay. Just now, right?
Yeah.
Okay. So here in the code lab, go to step 6. Are you able to see my screen now?
Yes.
Okay, go to step 6, which says advanced rank. If you go to the scroll down to the part where it says re-ranking, and right below that you will see a not so small query, but medium-sized query, which starts with initial ranking. You should be able to see my screen. So if you see here, the first snippet is the actual cosine similarity, which is the basic RAG which we have implemented. The next part is we have taken those results and re-ranked using the AI.rank method. As you can see right here, I'm choosing a model for my re-ranker as well, and re-ranked based on the search string, whatever string you want to search by. Like right now, we search for dress shoes, purple in color and whatnot. We gave some some other criteria as well. Pass your search string here, right? So it will re-rank your RAG results based on that. And on top of that, there is another thing that you can do, which is if operator, which is also there in this query. If you scroll further down, there is a LLM validation part right here, as you can see, which is logical filtering. Like some businesses will want accurate results for their users. They are not okay with approximate nearest neighbors also. So what they want to do is, on top of fetching the RAG results, RAG matches, they also want to run a re-ranker And on top of the re-ranked results, they also want to do an LLM based validation, which is like almost manual validation, which is like a human like validation, but like not exactly human validation. So how are we accomplishing that? So that's where we are going to use something called as an LLM validator. Here I think I've used Gemini, or also there is an if operator. Let me see. Logical filtering. Okay, here is that query. So this is the cosine similarity part. And this is the LLM validator part, where I have used LLM validator to say my prompt right here. All right. And then I'm validating the results with yes or no, a JSON response. If it does not match this criteria, don't send it to the user. Even if it is coming back in the vector search results, don't send it, is what I'm saying in this lab. There is also another thing called as if operator that AlloyDB supports, which on top of your, instead, if you don't want to use your own LLM validation method, you can call the AI.if operator, which will just take your prompt and your search text and say whether a certain response is allowed or not. Now you might be thinking, so why do I have to do all this cosine similarity, scan index, re-ranking and all that if I can just use the if operator? How many records will you use the if operator on? That's a catch, right? You need vector search, you need RAG, but this is after you have short, like from a list of 25 records to choose 5, you can use if operator. It's pretty fast, pretty efficient, and high in quality. You can always ensure like 100% accuracy for your, like recall is almost 100% for your search results. So that's when you need to go for approaches like that. This is like for advanced hybrid search cases where they want, I don't think there's any search e-commerce app out there that e-commerce app wise, because they want to push a lot of products. They say, okay, if it's not entirely purple but we have all the same stuff in yellow, do you want, they always want to convince the users. But this is for a scenario where you think that accuracy matters, right? So yeah, that's one thing I wanted to highlight. So go through this lab for recall as well. You'll just skip that part, but it's a simple method call that validates whether your application's recall is at 60% or at 90%. If 60% is okay for you, great. At real time, you can call this method and change your query parameters to make sure, query in the sense index parameters, to make sure your recall is always above 90% and only then return the search results. But that is an overkill. I wouldn't do that. But I'm just suggesting that's how how efficient this gets your search results, and how accurate it gets your search results. But you can always the recall evaluation method to validate your results for analytics purposes and at rest, which will really help in your business. Now, moving to the most important part, which is MCP toolbox for databases and application layer. Why is it the most important part? Because let's say you're a large enterprise with so many different parameters and so many different products and product lines and industries that you're maintaining databases for. Like one of it is in AlloyDB, maybe another one is in MongoDB or in Cloud SQL, or it's just stored in PDFs and stuff like that. Now you want to incorporate all of that together in one control plane. Like you saw in our Java application, did you see me write a line of query or something? No. Did you see me even include a dependency of AI there? No. Why? I have taken care of all of that in my database side. But where is the database side? What are you doing to the queries? I've not written that. Why? Because I'm letting MCP toolbox for databases take care of the entire database part for me. So how is that possible? It's pretty straightforward. You just go to, we'll do this in our fourth session, not the same application. There is another application, but for the same, this is not the same code lab. There's a different code lab, but for the same data set. So I'm not going to go through the steps right now. We'll do it on the fourth session, but we'll do something else that day. We'll see how to query the database from your toolbox, meaning to understand the schema and everything, how to talk to your database as you're talking to a command line interface, right? So we'll do all that in the fourth session. But for now, know that MCP server acts as an interface between your database and your AI application. So what is that interface? Where is the query? Show us the query. We've seen the query independently in the lab, but how it is used in the application, we don't know, is your question, right? So to answer that, MCP server, that is MCP toolbox for databases, is deployed as a server. And this server exposes all the database components to your application. So how does it expose? Everything in a simple single YAML file, So this is what the YAML file looks like. So let's go to our GitHub repository and see what our YAML file looks like. So as you can see right here, since I have only one database and one data set here, I only have one source with all the details of your connection credential, not all the connection details of your data source. And then you define the tools. So this is where the agent and the tools and all those things come into play. So how many tools do I have? I have multiple tools that cater to multiple applications. If you see, this is not just for this retail e-commerce application. I also have the toy store application in the same YAML. It's not a good practice, but I just maintain it so I don't lose it. But if you're thinking about a large enterprise which deals with multiple sources of data and multiple sources of application, you would go to the same approach where you maintain a single YAML where all your sources are defined in one place. And you use that to invoke the tool, and you can give access according to the tool for the specific requirement or the specific application that you need. Here, if you scroll down, our re-rank and filter query is here. Our retail facet filters query. This is the one I was talking about. This is what our application uses. So here is the actual query. If you can see right here, the prompt for LLM validation is here. The filters and other things are here. So the faceted filters, as I told you, the filters are formed at runtime. So let me show you that query really quickly. Okay, it's right here. This is the part where the faceted filters happen, the filtered vector search. So I have multiple queries just to separate one functionality versus other. There was another demo where I did filtered just the vector search and the performance, high performance and high quality vector search separately. So I have the queries in two different tools. One without performance and quality, just plain good old vector search. And the other one is good old vector search, which is enhanced with all the high performance and high quality parameters that we discussed. So that's why you see two. You have access to all of this. So please go through the queries. It's there in tools.yaml. So that's it. That's all I defined from a database perspective. Everything I needed, whether it's LLM validation or whatnot, is taken care of in the scope. It also supports, the best part is document databases. So even if you're using Firebase or MongoDB or Firestore, of course, Firebase is almost the Firestore is the cloud Firebase that you can use. Any database for that matter, this toolbox for databases allow you to connect to that. Just check out toolbox thing. Now, we've completed this particular lab today. For results, I really think, go to step 10. This is the one. The first, yeah, sorry. I'm sure. This is the one that you need to submit for result. The one that is highlighted in my screen right now. Go to step 10 of the code lab. The first screenshot under the topic, which is demo, the retail product search that you can see in my screen. Just take a screenshot of this and submit. You've all sat through a whole lot of theory today and also the hands-on part. You've completed it. So a lot of people put your hand up. So I'm sure you all completed it. So you can just, to make your lives easy, just take a screenshot of this particular first result and submit it in the result submission toolbox. Result submission app. I'm going to send you the link for the result submission app in the meeting chat right now. Your lab code should be the same for all the seasons. Doubt for deadline. Deadline is the last day of this season. Last day is 25, but you get until 20. What did I say before? 29, 11 p.m. Yeah. No, when the app is deployed, it doesn't cost anything because you're using AlloyDB instance that I have set up. So you will only be paying for the requests that you make, and that is also not paying. Like, you know how many requests you get free with a single instance of it. So don't worry about it. Since you have built a test application, I wouldn't encourage you to go post your Cloud Run application link on LinkedIn or anything. Don't do that. But if you're testing it and if you want to show a demo to your team or you want to present this somewhere else, you can always use it. It's going to be almost zero for this. You won't pay anything. All right, so play around with your application, submit the results, and we'll meet on Thursday, which is September 18th. We have another important session. What is our next topic? Also something related to MCP. Deploy a secure MCP server on Cloud Run. Again, Cloud Run based deployment, but for MCP server, you will be building your own MCP server. Even in today's session, you almost did it, but you did not know the details of it. But we'll do that in the session that follows. After the fourth session is actually accelerated full stack development with MCP toolbox for databases using Gemini CLI. So you will do both. We'll use Gemini CLI. We'll talk to our database and understand our database. And then we'll use MCP toolbox and deploy it in Cloud Run. So we'll do a lot more things. It's also not very time consuming. That's why I didn't cover those aspects in today's hands-on. Whatever hands-on part we missed today, you will cover it on September 22nd session, but not exactly the same way. You will do it differently. You will learn a lot different things from what we covered today. So I hope this session was useful. I'll stop recording first, and then maybe for 5 minutes we can just chit chat, and then I'll drop off. So should you.